In this video, we're going to look at a couple of review topics. One of them building series from known series, and another just looking at sum of a geometric. So this first one, it says, find the first three terms and general term of the Maclaurin series for the functions below using the series we already know. Well, I'm just going to make kind of a little note here. This is or looks a lot like 1 over 1 minus x, which was approximately 1 plus x squared, and so on, because it's the sum of the geometric series, right? It's the first term, 1 minus the ratio. So first term, and we're multiplying by x every time. So the only thing that's different is that instead of an x, I have a 6x. So I replace every x with a 6x. And it said just find the first three terms. I could simplify this a little bit. Like that. And there it is. Now the general term, well, the general term for this was just x to the n. So the general term for this new one, instead of x, it's 6x to the n. If you wanted to write 6 to the n, x to the n, you could, but there's your general term. Okay, let's go down because the number 3 is actually very similar. You'll notice that this we could rewrite as 4x multiplied by 1 over 1 minus x. So essentially, it's the geometric series, or geometric sum, multiplied by 4x. So what I can do is I can go back up here, and every term I can just multiply it by 4x. Since if I multiply this side by 4x, I multiply this side by 4x. All of this is very algebraic. Whatever you do to one side, you do to the other. So let me do that, okay? And said I'll write 4x times the first term plus 4x times the second term plus 4x times the third term, like that. Okay, so just notice what I've done. I've taken each term and I've multiplied it by 4x. And obviously I can clean this up to be 4x plus 4x squared plus 4x cubed, like that. Now, the general series, remember, for this was x to the n. Well, now it's 4x multiplied by x to the n. That's what I've done. I've just taken every term and I've multiplied it by 4x. And you could certainly clean this up to be 4x to the n plus 1 if you wanted. You wouldn't necessarily need to. Okay. Now I'm going to work over to actually sine of pi x. I'm going to kind of do a counterclockwise sweep here. So sine, remember, is approximated by x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, and so on. It's the it's the odds, so it's negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, that's the general term. Well, this isn't x, though. This is pi x. Pi x. So every place I see an x, I'm going to write pi x. So pi x minus pi x cubed over 3 factorial plus pi x to the 5th over 5 factorial. And that's it. We could multiply it out, but we don't really need to. And my general term, well, I have negative 1. It's still alternating. Instead of x to the 2n plus 1, it's pi x to the 2n plus 1, still over 2n plus 1 factorial. So there's my general term. Okay? Now, I want to point out, we're doing all these Maclaurin series. Nothing that we are doing is changing the fact that it's about x equals 0. Here we simply replaced, we changed the scale a little bit, but it's still about 0. Here we multiplied it by 4x, but it's still about 0. Here we maybe changed the period, but it's still about x equals 0. The minute you have a shift, like instead of pi x, it were x minus pi or something like that, that means you've taken the function and shifted it over Well, the Maclaurin series isn't going to line up anymore. So just be careful with that as you work, okay? All right, finally, 1 over 1 plus x cubed. I'm going to rewrite this as 1 over 1 minus negative x cubed. Make sure you see that that's the same thing. But now it looks like this. So every place I had an x, I'm going to write a negative x cubed. Okay, so it would be 1 plus negative x cubed plus negative x cubed squared. All right, so if we cleaned it up, we'd have 1 minus x cubed plus x to the 6th. And same type of thing with my general series. Instead of x to the n, it's negative x cubed to the n, like that. Or you could write negative x to the 3n if you wanted to, but you wouldn't have to. Finally, f of x is equal to that series. Then f of 1 is what? Well, remember what this means. Okay, let's write f of 1 is equal to this, and it's saying what is this equal to? What that's really saying is what is the sum? What would this be equal to if you added it up? So let's find the sum. The first term, if we started with k equals 1, if we plug that in, we'd have sine squared of 1 to the k. So sine squared, to the 1, so it would just be sine squared. And the ratio is whatever's being raised to the power, so it's that. So if I type this in my calculator, which I've done right here, I found the sine of 1, I squared it, and then I did first term over 1 minus the ratio, and I got 2.426.